Here's a map of our local superclusters, including the Virgo Supercluster. As you can see, galaxies and clusters of galaxies are not uniformly distributed in the universe. Instead, they collect into vast clusters, filaments, and walls of galaxies, interspersed with large voids in which very few galaxies seem to exist. A filament is constructed of galaxies and galaxy clusters. The Perseus-Pegasus filament is an example. Walls are much wider and thicker than filaments. Here we see the Fornax, Centaurus, Sculptor, and the Great Wall, or Coma Wall. The Great Wall is one of the longest known superstructures in the universe. It is approximately 200 million light-years away and measures over 500 million light-years long, 300 million light-years wide, and 16 million light-years thick. Voids are the vast empty spaces between filaments, which contain very few or no galaxies at all. There are 25 major voids in our local superclusters. Only a few are marked here. The Sculptor void is the largest in the nearby universe. Let's take a look at some of the superclusters and some of the galaxies photographed by Hubble that are contained in these superclusters. The Hydra Supercluster is close to the Virgo Supercluster and similar in size and shape to it. It's about 100 million light-years long and contains the large Hydra Galaxy Cluster. This map plots every bright galaxy in the supercluster. The galaxies in the supercluster range from 150 to 200 million light-years away. Here's a picture of the Hydra Cluster. Two stars within our own Milky Way galaxy can be seen in the foreground. There are three large galaxies near the cluster center, two yellow ellipticals and one prominent blue spiral. These are the dominant galaxies, each about 150,000 light-years in diameter. And here's an interesting overlapping galaxy pair, cataloged as NGC 3314. We'll take a closer look at this one. Through an extraordinary chance of alignment, a face-on spiral galaxy lies precisely in front of another larger spiral. This lineup provides us with the rare chance to visualize dark material within the front galaxy, seen only because it is silhouetted against the object behind it. The bright blue stars forming a pinwheel shape near the center of the front galaxy have formed recently from interstellar gas and dust. A small red patch near the center of the image is the bright nucleus of the background galaxy, NGC 3314b. The Centaurus Supercluster is the closest neighbor of our Virgo Supercluster. It contains a number of large galaxy clusters, including the Centaurus cluster. The galaxies in the supercluster range from 150 to 200 million light-years away. This map plots the brightest galaxies in this area of the sky. The Centaurus cluster is a swarm of hundreds of galaxies, 170 million light-years away. The cluster is filled with gas at temperatures of 10 million degrees or more, making it a luminous source for cosmic X-rays. Here's a magnificent view of the spiral galaxy NGC 4603 in the Centaurus cluster. It is the most distant galaxy in which Cepheid variables have been found. Clusters of young bright blue stars highlight the galaxy's spiral arms. In contrast, red giant stars in the process of dying are also found. Only the very brightest stars in NGC 4603 can be seen individually. Much of the diffuse glow comes from fainter stars that cannot be individually distinguished. Here is another galaxy in the Centaurus cluster. The image shows NGC 4622 and its outer pair of winding arms full of new stars shown in blue. Astronomers are puzzled by its clockwise rotation because of the direction of the outer spiral arms are pointing. Most spiral galaxies have arms of gas and stars that trail behind as they turn. But this galaxy has two leading outer arms that point toward the direction of the galaxy's clockwise rotation. Located about 130 million light-years away in the Centaurus cluster, NGC 4650A is one of only 100 known polar ring galaxies. Their unusual disk ring structure is not yet well understood. One possibility is that polar rings are the remnants of colossal collisions between two galaxies sometime in the distant past, probably at least 1 billion years ago. NGC 4696 is an elliptical galaxy in the Centaurus cluster. In fact, it is the brightest galaxy in the cluster. This composite image was taken in a study of the galaxy's central black hole. It shows a vast cloud of hot gas in red, surrounding high-energy bubbles 10,000 light-years across in blue. The green dots in the image show infrared radiation from star clusters on the outer edges of the galaxy. New observations from Hubble have revealed the intricate structure of the galaxy in greater detail than ever before. Astronomers have found that each of the dusty filaments has a width of about 200 light-years. These filaments knit together and spiral inwards toward the center's supermassive black hole that's flooding the galaxy's inner region with energy, heating the gas, and creating streams of heated material. It appears that these hot streams of gas bubble outwards, dragging the filamentary material with them as they go. The galaxy's magnetic field is also swept out with this bubbling motion, constraining and sculpting the material within the filaments. The Perseus-Pisces Supercluster is a long, dense wall of galaxies with a length of almost 300 million light-years that is around 250 million light-years away. It is one of the largest known structures in the universe. This plot of the brightest galaxies in the supercluster show how prominent it is. At the left end of the supercluster is the massive Perseus cluster, one of the most massive clusters of galaxies within 500 million light-years. Here we have the Perseus Galaxy Cluster, containing thousands of galaxies immersed in a vast cloud of hot gas. It's moving away from us at over 5,000 kilometers per second. That's almost 2,000 miles per second. Inside this galaxy cluster, Hubble discovered a very old and rare galaxy moving through the cluster at 3.2 million kilometers per hour. That's 2 million miles per hour. It is thought that NGC 1277 has remained essentially unchanged for the past 10 billion years. The evidence that this is the case lies in the ancient globular star clusters that swarm around it. Massive galaxies like this one tend to have both newer blue and older red globular clusters. Red ones are believed to have formed as the galaxy formed. Blue ones are brought in later as the galaxy merges with others. However, NGC 1277 is almost entirely lacking in blue globular clusters. One explanation says, because of its speed of transit through the cluster, it cannot merge with other galaxies to collect the stars and pull in the gas to fuel star formation. Here we are zooming into the giant elliptical galaxy NGC 1275 in the Perseus cluster. we see fine, thread-like filamentary structures in the gas surrounding the galaxy. The red filaments are composed of cool gas, being suspended by a magnetic field, and are surrounded by the 100 million degree hot gas in the center of the Perseus Galaxy Cluster. The filaments are dramatic markers of the feedback process through which energy is transformed from the central mass black hole to the surrounding gas. The filaments originate when cool gas is transported from the center of the galaxy by radial bubbles that rise in the hot interstellar gas. The Coma Supercluster is a nearby supercluster of galaxies that includes the famous Coma cluster, Abell 1656. The supercluster is located 300 million light-years from Earth. It is roughly spherical, about 20 million light-years in diameter, and contains more than 3,000 galaxies. Being one of the first superclusters to be discovered, Coma Supercluster helped astronomers understand the large-scale structure of the universe. Here we are zooming into the immense Coma cluster of over 1,000 galaxies, located 300 million light-years from Earth. The Coma cluster has received a huge amount of scientific research. This is partly because it lays a long way from the plane of our galaxy, and it is largely unobstructed by any gas, dust, or foreground stars. Hubble was used to do a comprehensive study of the Coma's globular star clusters. They found over 22,000 of them, circled in green. They found globular clusters scattered in space between the galaxies, ripped from their home galaxies by near collisions with other galaxies. Astronomers will use the globular cluster field for mapping the distribution of matter and dark matter in the Coma Galaxy Cluster. Here we are zooming into NGC 4921. It is one of the rare spirals in the Coma cluster, and a rather unusual one. It is an example of an anemic spiral, where the normal vigorous star formation that creates a spiral galaxy's familiar bright arms is much less intense. As a result, there is just a delicate swirl of dust in a ring around the galaxy, accompanied by some bright young blue stars. NGC 4911 contains rich lanes of dust and gas near its center. These are silhouetted against glowing newborn star clusters and iridescent pink clouds of hydrogen, the existence of which indicates ongoing star formation. 4911 and other spirals near the center of the cluster are being transformed by the gravitational tug of their neighbors. In the case of 4911, wispy arcs of the galaxy's outer spiral arm are being pulled and distorted by forces from a companion galaxy, NGC 4911A, to the upper right. The resultant stripped material will eventually be dispersed throughout the core of the Coma cluster, where it will fuel the intergalactic population of stars and star clusters. Here are the distances to a few additional superclusters in our local group. Hercules is 400 million light-years away. Leo is 450 million light-years away. Shapley is 500 million light-years away. Horologium is 900 million light-years away. And Corona-Borealis is 1 billion light-years away. It has always been difficult for astronomers to determine where one supercluster ends and another begins. But now a team of astronomers have collected data on thousands of galaxies around us to understand their peculiar motion. The peculiar motion of an object is its motion less that part of its motion associated with the Hubble flow due to the expanding universe. They use this data to identify which galaxies are moving towards us, shown in blue, and which galaxies are moving away from us, shown in red. With this data, they were able to create a map of the paths galaxies are migrating along. These paths are called cosmic flows. Using this motion, they came up with a new way to map the distribution of matter in the universe. In our segment on the Virgo Supercluster, we counted the Virgo Galaxy Cluster and a few hundred others as our local supercluster. But using this new technique, we see that the Virgo Supercluster is part of a much larger structure that is 100 times larger and more massive. The astronomers who made this discovery have named the new supercluster Laniakea, Hawaiian for immeasurable heaven. Here is an illustration of Laniakea, along with Perseus-Pisces and adjacent supercluster. The boundary is where the supercluster objects are shearing apart, like the North American Great Divide separates water flowing to the Atlantic Ocean from water flowing to the Pacific Ocean. In this view, the red dot shows our Milky Way's location in Laniakea. Now let's take a look at a few more galaxies found in our local superclusters. This is an image of an unusual edge-on galaxy, revealing remarkable details of its warped, dusty disk. The strong warping of the disk indicates that this galaxy has recently undergone a collision with a nearby galaxy and is in the process of swallowing it. In the outer regions, especially on the right-hand side of the image, we see that the twisted disk contains not only dark dust, but also bright clouds of blue stars. This shows that hot young stars are being formed in the disk. Astronomers believe that the formation of new stars may be triggered by collisions between galaxies as their interstellar clouds smash together and are compressed. This spiral galaxy played host to a supernova explosion back in 2012, known as SN 2012 IM. Now another star has exploded, forming supernova SN 2013 EK, visible in this image as the prominent star-like bright object just slightly above and to the right of the galaxy's center. The observations that make up this new image were taken on the 19th of August 2013, and aim to pinpoint the location of this new explosion more precisely. It is so close to where SN 2012 IM was spotted that the two events are thought to be linked. The chance of two completely independent supernovae so close together, exploding within 1 year of one another, is a very unlikely event. The appearance of a galaxy can depend strongly on the color of the light with which it is viewed. This galaxy, when seen in visible light, exhibits tightly wound spiral arms that give it a pinwheel shape, similar to that of many other spirals. However, when the galaxy is viewed in ultraviolet light, its shape is startlingly different. Ultraviolet light has a shorter wavelength than ordinary visible light and is emitted from stars that are much hotter than the Sun. At ultraviolet wavelengths, which are rendered as blue in this Hubble image, we see a spectacular, nearly circular, bright ring surrounding its nucleus. The ring marks the presence of many recently formed hot stars. This is ESO 137-001, a part of the Norma Galaxy Cluster. The image not only captures the galaxy and its backdrop in stunning detail, but also includes intense blue streaks streaming outwards from the galaxy, seen shining brightly in ultraviolet light. These streaks are actually hot young stars encased in wispy streams of gas that are being torn away from the galaxy by its surroundings as it moves through the Norma cluster. This violent galactic star extraction is due to a process known as ram pressure stripping, a drag force felt by an object moving through a fluid. The fluid in question here is superheated gas that exists at the center of galaxy clusters. NGC 5548 is a well-studied Seyfert galaxy with a bright, active nucleus. This activity is caused by matter flowing into the 65 million solar mass supermassive black hole at the core. The disk is heated so much that it emits X-rays near to the black hole, and less energetic ultraviolet radiation further out. The ultraviolet radiation can create persistent winds strong enough to blow gas away from the black hole. NGC 5548's persistent wind, which has been known about for 2 decades, reaches velocities exceeding 3.5 million kilometers per hour. That's 2.1 million miles per hour. But a new wind has arisen, which is much stronger and faster than the persistent wind. The new wind reaches speeds of up to 18 million kilometers per hour. That's 11 million miles per hour. But is much closer to the nucleus. This activity could provide insights into how supermassive black holes interact with their host galaxies. This spectacular Edge-on galaxy is believed to be the home of an intermediate mass black hole that may have been stripped off of a cannibalized dwarf galaxy. The estimated 20,000 solar mass black hole lies above the galactic plane. This is an unlikely place for such a massive black hole to exist unless it belonged to a small galaxy that was gravitationally torn apart by this one. The circle identifies a unique X-ray source that pinpoints the black hole. Here we are zooming into Stephan's quintet. As the name implies, it is a group of 5 galaxies. The name, however, is a bit of a misnomer. Studies have shown that group member NGC 7320 is actually a foreground galaxy. At 40 million light-years, it is about 7 times closer to Earth than the rest of the group. 3 of the galaxies have distorted shapes, elongated spiral arms, and long gaseous tidal tails containing myriad star clusters, proof of their close encounters. These interactions have sparked a frenzy of star birth in the central pair of galaxies. 7319 is a barred spiral galaxy with distinct spiral arms that follow along 180 degrees back to the bar. Continuing clockwise, the next galaxy appears to have 2 cores, but it is actually 2 galaxies, 7318A and 7318B. NGC 7317 is a normal-looking elliptical galaxy that is less affected by the interactions. These farther members are markedly redder than the foreground galaxy, suggesting that older stars reside in their cores. This visible light Hubble picture reveals an intergalactic pipeline of material flowing between 2 battered galaxies that bumped into each other about 100 million years ago. The pipeline, the dark string of matter, begins in 1410, the galaxy on the left, crosses over 20,000 light-years of intergalactic space, and wraps around 1409, the companion galaxy on the right. New images from Hubble show D100, a spiral galaxy, being stripped of its gas as it plunges towards the cluster's center. A long, thin stream of gas and dust stretches from the galaxy's core and on into space. The tail, a mixture of dust and hydrogen gas, extends nearly 200,000 light-years. But the structure is comparatively narrow, only 7,000 light-years wide. We saw this ram stripping earlier with galaxy ESO 137-01. Eventually, the galaxy will lose all of its gas. Without the material to create new stars, star formation in the galaxy will cease. It is estimated that the gas stripping process in D100 began roughly 300 million years ago. Adding to this story is another galaxy in the image that foreshadows D100's fate. The object, named D99, began as a spiral galaxy similar in mass to D100. It underwent the same violent gas loss process as D100 is now undergoing, and it can no longer form new stars. Here we are zooming into three galaxies that appear to be partially overlapping in the image, although they may be at somewhat different distances. The spiral shapes of two of these galaxies appear mostly intact. The third galaxy, on the far left, is more compact, but shows evidence of star formation. This image shows the diverse collection of galaxies in the cluster Abell S0740. The giant elliptical ESO 325-G004 looms large at the cluster's center. In the course of analyzing this Hubble image, astronomers discovered that ESO 325 is actually a gravitational lens. This means that the focusing power of the enormous mass making up the galaxy caused the light from some distant object, probably a distant dwarf galaxy, to be deflected and magnified. As a result, the more distant galaxy appears brighter and distorted into the shape of an arc or ring, known as an Einstein ring, because the phenomenon was first predicted by Albert Einstein. A nearly perfect ring of hot blue star pinwheels about the yellow nucleus of an unusual galaxy known as Hoag's object. A blue ring, which is dominated by clusters of young massive stars, contrasts sharply with the yellow nucleus of mostly old stars. What appears to be a gap separating the two stellar populations may actually contain some star clusters that are just too faint to see. Curiously, an object that bears an uncanny resemblance to Hoag's object can be seen in the gap at the 1 o'clock position. The object is probably a background ring galaxy. There's one more thing about the galaxies in our local superclusters. They all have an unusual, peculiar motion. Normally, galaxies are expected to have a motion consistent with the Hubble flow. That is, given Hubble's law and the distance to a galaxy, its velocity is set. But in our local area, within 1 billion light years, there is an additional flow superimposed on the Hubble flow. It appears that our galaxy and a large number of the galaxy clusters in our area are flowing towards what is called the Great Attractor. Our velocity is estimated to be around 700 kilometers per second towards this point. That's 435 miles per second. Recent observations indicate that the point is the place all the galaxies in the Laniakea Supercluster are moving. The mass at this theoretical location is estimated to be thousands of times more than the mass of the entire Milky Way. Here's a panoramic view of the entire sky as seen in near infrared. It shows the distribution of galaxies beyond the Milky Way. The galaxies are color-coded by redshifts obtained from various sky surveys. Bluish-purple are the nearest sources, within 140 million light-years. Green are at moderate distances, out to 600 million light-years. And red are the most distant sources, out to 1 billion light-years. Initially, it looked like the Great Attractor was located close to the Norma cluster. But Norma is so close to our galactic plane, or area of avoidance, that we cannot see into it very well. More recently, updates of motion vectors indicate that the flow is not so much to the Norma cluster, but to the much more massive Shapley Galaxy Cluster. As you can imagine, understanding this peculiar flow is an area of active research. Here I have marked the galaxy clusters and local superclusters we covered in this segment. Within this 1 billion light-year radius from us, there are 100 superclusters, 240,000 galaxy groups, 3 million large galaxies, 60 million dwarf galaxies, and 250,000 trillion stars. At this range, the Milky Way is too small to show up. Our entire local volume is little more than a dot. But the entire map only represents about 7% of the entire visible universe. In this segment, we've seen several interacting galaxies. So before we conclude the video book covering the cosmos as a whole, we'll take a closer look in our next segment at what it means for galaxies to collide.